Hey guys, welcome back. Today is day 15. We are starting off with the third week, and today's first problem, this week's first problem is product of array except self. So we are given an array, and we are told that for given an array nums of n integers where n is greater than 1, return an array output such that output of I is equal to product of all the elements of nums except nums of I. So whatever I we are calculating the output for, it will be product of all the elements of the array except for the current element. So if this is the sample input that they have given 1 2 3 4, and as you can see 24 is the product of all the elements except one. So 2 multiplied with 3 and 4 will give us the output of 24. And if you think about 12, the second element, it is a product of 3 4 and 1, 4 3 and 1. So the same way we can find output for each of the element. Now, the straightforward solution in this case would have been to multiply all the elements together and just divide it with whatever element is present at the current index. So we could have directly multiplied all the four numbers and store it in a value, and then to get the output array, we can just divide with whatever I we are iterating over. However, it is given that we have to solve it without using division, and we have to solve it in time complexity of linear time. So you can iterate through the array once. So basically, you have to do it in linear time, not once. Um, Also it is the constraint that is given is we can assume the product of all the elements of prefix or suffix of the array, including the whole array, can be fit into 32-bit integers. So we don't have to worry about the overflows. There is a follow-up question which I was not able to solve. So if you can find a solution without using any extra space, then please let me know in the comments. However, for the current solution, I'll be using an extra space. So let me explain the problem. What I'm doing is, let's say this is the given array. The array contains 2, 3, and 4. I'm going to create two arrays which will store the cumulative product from left to right and from right to left. So this is pretty similar to what we did earlier for cumulative sum. So what left to right does is it will start multiplying the elements from left to right and store those values in the array. So 2 will be stored as it is. 3, the second element will be multiplied with all the elements from the starting. So 2 and 3, the product of these two will be stored as the second element, which is 6. And for the third element, we'll be storing the product of all the three elements, that is 4 multiplied with 3 and 2. The same way we do it for right to left array, but in this case we'll be doing it from right to left. So 4 will be stored as it is. The second last element will be multiplied with all the elements up to the end. So 4 multiplied with 3 will be stored as 12, and the final output is going to be same 24, which will be the multiplication of all the numbers. So how do we find the result from this two arrays? Well, it is easy. So what we can do is for any element, it will be product of whatever is present in the left to right, uh, the the previous index in the left to right, and the next index in the right to left array. So the product of these two elements will give us the current elements index. So let's consider how do we get the element 8. So 8 can be obtained by the previous element in the left to right index, left to right array, which is 2, and the next element in right to left array, which is 4. So product of 2 and 4 will give us 8. But for the extreme points, we'll be finding that there is no element in the left to right array. So it will be just considering the right to left array to find the first element. So in this case, it will be the output will be 12, and for the last element, uh, the output will be obtained from left to right array. So this is what I'm planning to write. So what I'll do is I'll create two arrays, left to right, and the arrays will be the same size as the input array. So this is my left to right array, and the second array will be right to left, and cumulative product, it will be, let's say initialize it to, I have to initialize it to 1 because I'll be multiplying with other numbers. So I'll iterate through the input array and fill my left to right array. So I'll start off with index I from 0, and the left to right result for index I can be obtained by using the cumulative product multiplied with whatever element is present in the input array, and we'll update the cumulative product to whatever value we just calculated and stored at the index I. Now something similar will be done for right to left array as well, but in this case we'll be starting off from the extreme right. So let me create a variable length which will store the length of the array, and we'll be starting off from length minus 1, and this will continue as long as j is greater than equal to 0, and j will be decremented at each point, and the right to left array for a particular index j will be again cumulative product, but ideally we should initialize again the cumulative product that we obtained because it has been updated. So the cumulative product and nums of j will be multiplied, and the cumulative product will be updated at each point of iteration with whatever value was calculated. Now that we have our left to right and right to left arrays filled, we can just iterate through the array again and create our output result. So in this case, what I'll be doing is rather than creating a output array separately, we can directly manipulate the input array itself and return the input array. So I'll be manipulating the nums array, the input array. So what I'll do is nums of I can be obtained from left to right of index minus 1 multiplied with right to left element. Right to left array is index plus 1, and for the extreme cases when I is equal to 0, in this case only right to left element will be, right to left array will be used. So right to left array of whatever index plus 1 can be used, and for the other extreme case, which will be when I is equal to length minus 1, for the extreme right, the result in that case will be obtained from left to right array, which will contain uh, and this will be the final result for all the middle elements. And yeah, that should be, this is a linear time algorithm, since we are every time we are iterating through the array just once, and but we are using extra space for storing this left to right and like right to left arrays. So let's run this and see if yeah, so our output is matching the expected output, and I'll submit this solution. Let's see if this works. Yeah, so our solution is accepted, and all the test cases have passed, and it is saying 100% better than all the possible solutions. So yeah, so if you like this video, give it a thumbs up, and do subscribe to my channel if you want to be notified about when I upload the day 16 problem. So thank you.